Disadvantages of the Mapleson system include a requirement for high fresh gas flow rates, resulting in wasted anesthetic gases and increased cost, as well as OR pollution. High fresh gas flow also makes assessment of spontaneous ventilation difficult and can lead to potential hazards if the oxygen supply is inadequate to meet the demand. Incorrect arrangement of components can lead to large increases in dead space and inadequate exchange of gas. Location of the APL valve near the patient's face in the Mapleson A, B, and C make for an awkward configuration. The Mapleson E and F configurations are difficult to scavenge, and in the event of malignant hyperthermia, the anesthesia provider may not be able to increase the fresh gas flow enough to remove excess CO2. Finally, we will discuss the circle system. The essential components of the circle system are the CO2 absorber, 2 unidirectional valves, fresh gas entry, Y-piece to connect to the patient, reservoir bag, a relief valve, low resistance interconnecting tubing. Efficient functioning of the system requires the presence of 2 unidirectional valves on either side of the reservoir bag. A relief valve, or APL valve, should be positioned in the expiratory limb only. The fresh gas flow should enter the system proximal to the inspiratory unidirectional valve. During inspiration, the fresh gas and CO2-free gas that passes through the CO2 absorber from the reservoir bag flow through the inspiratory limb and inspiratory unidirectional valve to the patient. No flow takes place in the expiratory limb as the expiratory unidirectional valve is closed by back pressure transmitted to the valve. During expiration, the inspiratory unidirectional valve closes and the expired gas flows through the expiratory unidirectional valve in the expiratory limb to the CO2 absorber and to the reservoir bag. The CO2 is absorbed in the canister. The fresh gas flow from the machine continues to fill the reservoir bag. When the reservoir is full, the relief valve opens and the excess gas is vented to the atmosphere. By adjusting the APL valve, the expired gas can be selectively vented when the fresh gas flow is more than the alveolar ventilation. To facilitate controlled ventilation, the APL valve has to be partly closed and excess gas is vented during inspiration. Some of the advantages of the circle system include conservation of heat and moisture, accurate control of the inspired concentration of anesthetic gas, less OR air pollution, economy of gas with low fresh gas flow, control of CO2, and the circle system is not reliant on tubing length for adequate gas delivery. With 10 different connections in the system, the potential for disconnection is high. Circuit disconnect is one of the most common causes of anesthesia mortality and morbidity, and is the main disadvantage of the circle system. This concludes my presentation on anesthesia breathing systems. Thank you.